All right, so I'll explain the Q learning using this following example. So this is the example that we will be implementing in the notebook. Okay, this car over here doesn't have the full power to just go all up the hill over here. It has got power, but it is a very limited power. So what we need to do is to kind of like use this small power to swing back and forth until we generate enough momentum in order to reach this final destination over here. So let me give you an idea of what will be happening. So in this situation
Cool.
over
Okay,
here,
so everything's
you know, the car is not moving properly, so it's not able to grow that swinging momentum. Now, after some training, the car has improved, and right now it's able to reach more and more along the way. So what we hope to learn is how to move the car, when to move the car kind of like right, and when to move it left, and when not to do anything in order to swing and build that momentum properly and reach the end point over here. So this is what we're going to be learning. So the system that we're going to be working with is the following. At each at each instant, we will have a position for this car. Okay, so we'll have a position, and also we will have a velocity. Okay, we can also add the acceleration or the next level derivative. So the position and the velocity and the acceleration, if you want, whatever you decide, is called the state because it describes the state of the current situation. Now, based on the state, which is the position and the velocity in our situation, we will take an action. Okay, so the action will be to push right, do nothing, or to push left. Okay, so those are our three potential actions. Okay, so right now we understand the state, which describes the state of our situation, and we also understand the action. Those are two of the very fundamental concepts that we should understand. Now, based on this state, we will take one of those three actions. And once we take one of those three actions, we will get a response from the environment. Okay? So the environment will return a reward for us. If that was a good action, it will return a high reward. If that was a bad action, it will return a small reward or a negative reward based on whatever you program the environment to do. So, whenever we take a good action, the environment will return a good reward or a large reward. Whenever we take a bad action based on our state, the environment will return a small reward or a negative reward. So, right now, we understand the state, we understand the actions that we will take based on the state, and we also understand the reward or the concept of the reward. So right now we can start talking about the Q table. All right, so this is our Q table over here. For each state and action, we have a value. For example, let's say 1 over here. Okay, 3 over here, 5 over here. So this value we call the Q value. So for each action and state combination, okay, we have a Q value. This Q value determines how likely we are supposed to take the action based on that state. So in our situation, each state is a position and velocity range combination. So whenever the position is, let's say, between 0 and 1, and the velocity is between 0 and 1, this is considered, for example, state 1. whenever the position and the velocity are in a different range, we are in state 2 and then state 3. And so for each combination of position and velocity, we have a particular state over here. Okay? And for each action and state, we have a Q value. So what are the actions in our situation? Turn left or push towards the left, push towards the right, or do nothing. Okay? Left, right, and nothing. So how would the system work right now? If we are in state 1 right now, okay? So it happens that the car right now is in, let's say, this position over here. We will go to our Q table over here and pick the action that has got the highest Q value. So in our situation over here, okay, let's assume that this action has got the highest Q value over here. So we will perform that action. Okay, yeah. Now, in the beginning, we will initialize the Q table with random values or maybe with zeros, whatever suits you all. Okay, we will initialize it with random values or small values. And right now, we will start the reinforcement learning process and we will start updating this Q table over here and modifying its values based on the feedback we get from the environment, which is the reward. So every time we are at a certain state and we take a certain action, okay, we will modify the corresponding Q value based on the feedback or the reward we get from the environment. So right now, we will be talking about the update equation, which is the equation that we will be using in order to update those Q values based on the reward we get from the environment. So what we aim for right now is to get a table with the right Q values so that every time we are in a certain state, okay, the best action will have the highest Q value over here. So that every time we go to that particular state from the table and we choose the maximum Q value from here, or we will choose the action that has got the highest Q value. This is our final goal. So this is the equation that we will be using in order to update our Q table as we iterate throughout the environment. Okay. So I don't like this equation. It's written in a way that makes it look complicated. It's very simple, actually. Now, the very, very basic concept that we can use in order to update our Q table is very simple and instinctual, which is to add the reward that we get back from the environment to the original Q value. So if the Q value of the action was 5 and what we got a reward from the environment of, let's say, 3, so we will say our new Q will equal, this is just a very simple kind of like way, 5 plus 3, right? That's kind of like instinctual, okay? So to a certain level, we are doing this in this equation. What are we saying? We say that the new Q value over here will equal the old Q value over here plus the reward over here, right? Okay. So right now we understand this term over here, which is adding the reward that we got back from the environment to the original Q value over here. Now, in order to get more options, we will do the following. Okay. Let's say that we want 70% of the new Q value to come from just from the based on the old Q value and 30% to be based on the new reward over here. So let's call this 70%, 30%, let's call it the learning rate, okay, which is this one, Okay, so let's call this, okay, so let's assume that this one is 30%. Okay, so this learning rate will determine how much we change based on each iteration. So if this learning rate is very high, so we will be changing very rapidly. If it's low, we will be more stable in our learning. So right now, when we say that the learning rate is 30%, it means that right now this will be multiplied by 70%, right? Because 1 minus 30% will be 70%, right? So, so it means that 70% of this new Q value will be based on the old Q value over here, and 30%, this is 30%, right? Okay, will be based on the new reward, or on the reward that has resulted from that action. Okay, so right now we understand what is this 1 minus learning rate, and the learning rate over here just determines how much percentage of the new value will be based on the old Q value that was initially in the table, and how much percentage will be based on the reward that has resulted from the action. So smaller learning rate will result in a more stable system, right? If this was very high, it will totally depend on the reward or on the new results. Okay, so the equation is very simple, right? So now we understood this one, okay, and now we understood this one. One last remaining thing is this term over here. What is this? In order to understand why did we add this term over here, let's have the following example. Okay, assume that you have decided to open a business, okay, and first you have to select a product, okay. So first you need to select a product. So this product is like kind of like this action over here at T, the action at T. Now, after selecting the product, this is QN. After selecting the product, you should run a campaign. Okay. And this campaign will depend definitely on the product which you have picked. So let's say that what is the maximum reward for this campaign based on the product which you have selected. So if you have selected a good product, the campaign will be very rewarding, right? If you have selected a terrible product, the campaign will not be rewarding no matter what you do. If you have a bad product, the campaign will be bad. So the result of the campaign will depend on the initial choice. So choice 1 will dictate what happens with choice 2, and so on and so forth. So if the choice at step 1 has resulted in a very highly rewarding process at step 2, then definitely this choice was a good choice, right? So this is why we ask ourselves, what is the highest Q value? What is the highest Q value that we can get, assuming that we have taken the action at this previous step? So this term, we ask ourselves, assuming that we have taken this action, okay, and transition to the next state, what is the highest Q value that we can get based on the next state? If it was a good state, if it was a strong position, it will generate a very high reward. If it was a bad position, if this step, initial step, has taken us to a bad position, or has put us into a hard position, like for example, picking a bad product over here, then it will result in a non-rewarding action at the very next step. So I hope right now that the update equation, it's a very simple equation. You can, if this looks very complicated for you, you can just simply say that Q new, okay, equals Q old. This you can start with this one as a beginner, right? Plus R, okay, plus R. Or maybe you don't want R, you want kind of like just a percentage of R, for example. Okay, so this is kind of like the very basic shape. Now, once you want to improve things out, you will arrive at this equation over here. Now, this is everything that you need to know about the Q learning process. Now, let's have a walkthrough into the code and the Colab notebook. All right, now let's have a quick look at the code over here. All right, we have this code over here. We will use this gem package for reinforcement learning. Okay, and we'll use a function called make in order to establish the environment. It's called the mountain car environment over here. All right, so over here, we have initialized the Q table, okay, with some random values. Okay, some we have started with whatever random values to start with. Now, as we said before, that we will take the action that has got the maximum Q value. So we will argmax or take the maximum, uh, uh, we'll take the action with the maximum or the highest Q value. Okay, so we will take this action over here and we will apply it into the environment. We will use a function called step. End.step means take the action that we have selected over here and apply it to the environment. Okay, so, and right now over here, we have got our update equation. Okay, which we have talked about over here, 1 minus the learning rate times the current Q plus the learning rate times the reward. Okay, so we have applied the action to the environment and we have gotten a reward. So, and we can use this reward in the update equation over here. And then we will update the Q table with the new Q, as we can see over here. Those are the most important parts, okay, of the code. The rest is just for printing and logging purposes. All right. Now, the last part is about the application of the SVD. So every certain number of epochs, now our training, each training ground will be called an episode, right? Now, every certain number of episodes, we will bring our Q table and we will decompose it into the SVD components. And then, in order to smooth it out, we will take the top 3 or n singular values. In our situation over here, for example, we'll take the top 3 singular values over here, and then we will reconstruct the Q table back based on the okay, and then we will reconstruct back the Q table. Okay. Now the benefits of doing that are pointed out in the documents. All right, the last thing we'll do over here is just to run this code, make sure that all those pip install lines are activated. And let's run this one out, okay? And look at the training process. I have programmed the code in order to print out the highest position reached, okay, in order to look at the performance that we have reached. Okay, so right now it has trained very nicely. Okay, and this is the highest position reached. So the code has actually accomplished the task. Okay, if we kind of like, let's do one more thing. Start. I will reduce the number of epochs in order to see how it doesn't reach the final position in the first few episodes. Let's say, for example, let's start with 20 episodes. Okay, let's run this and see what is the highest position reached based on just only 20 position episodes, sorry. Okay, now this is it. Now this is based on 20 positions. This is the highest position reached. Okay, now if we increase the number of episodes to kind of like maybe 200 or something like that, it will accomplish the task as we have seen before.